So the first section here, these are questions from 3.5. So let's take a look at, let's do number 4 together. So we always want to set the smaller equation equal to whatever variable is not squared. So notice how in the second equation here, y is the variable that's not squared. So I want to make this first equation y equals. So what would I need to do to make it y equals? Add x. Perfect. So we're going to add x, move it to the other side. So I get y equals 4 plus x. So now I can take this and plug it into the y in the other equation. So this is just like substitution that we did before. The only difference is what makes it 3.5 is because we have that x squared. But it's the same thing. We're substituting it into our other equation. So we have negative x squared minus 2x plus 4 plus x is equal to negative 16. What should we do next? Combine like terms, and what else? We want to make it equal to 0. Why? Why do we want to make it equal to 0? To be able to factor. Notice how we have an x squared. If you have an x squared and an x, you have to factor to solve. So let's combine all of our like terms. I'm going to add 16 to move it to the other side, and then add the x's together. So I get negative x squared minus x plus 20 is equal to 0. Now we can't factor this normally because my x squared is negative. How would I make it positive? What should I do? Divide everything by -1. Perfect. We always like it when our leading coefficient's positive. So let's divide it by -1. We're going to change the signs of everything. So that gives me x squared plus x minus 20 is equal to 0. Now we can factor it normally. What are two factors of -20 that add to 1? 5 and 4. Which one's negative? 4. Perfect. So I have x plus 5 and x minus 4 equals 0. What would I do next? Set them both equal to 0 and solve. So x plus 5 equals 0. X minus 4 equals 0. So what does x equal? -5 and 4. Now going back to the original question, do I only have x's in the question? No, I have y's too. So I have to find the y also. How do you think I can find the y? Plug in the x. So I'm going to plug in the x's. I'm going to plug it into the first equation because it's smaller. So I'm going to plug it into the x in the first equation. So I have -5 plus y is equal to 4. So 5 plus y is equal to 4. I subtract 5 on both sides. So y is equal to -1. So when I plugged in -5, I got -1. So I would write this answer as -5, -1, just like we did with our x's first. We also have to plug in the other x. So I have -4 plus y is equal to 4. Add 4 to both sides. So y is equal to 8. How would I write this answer? 4, 8. So these would be our two solutions. So we had two values for x here and here. So I'm going to take it and plug it back into the original equation, which is the math that I did over here. So just plug in one at a time. We plugged in -5 first, then found what y is equal to, and then plugged in 4 here, and then found what y is equal to. So when you factor, you're going to have two answers, so you're going to have two different answers for y. So you'll have 2 points here as your answer. All right, let's look at the next one, graphing. So this is 2.2. So given each function, identify the requested information and graph. Is this in standard form or vertex form? Standard form. Remember, vertex form is the one with parentheses where we can identify our vertex immediately. Here, it's standard form, so I need to use the formula to find my vertex and axis of symmetry. What is the formula? Negative b over 2a. Make sure you know this for tomorrow. This gives us the first number in the vertex. And also the axis of symmetry. So what's our A? 1. What's our B? And what's C? 0. There's nothing here, so C would be 0. Not always. It's always like the constant, what you're adding. So like the number in front of the x squared is your A, the number in front of the x is B, and then the constant is going to be your C. Here we don't have a constant, so it's 0. We'll do the next question.
C is the y-intercept. Right?
C is the y-intercept,
so
yes.
In this case, the y-intercept would be 0, 0.
Yes. But let's find our vertex first, and then we'll get there. So let's plug in our A, B, and C. I have negative 2 over 2 times 1. Which would be negative 2 over 2, which simplifies to what? Negative 1. So the first number in my vertex is negative 1, and that also means my axis of symmetry is negative 1. How do I write my axis of symmetry? Nope. Axis of symmetry is a line. X equals negative 1. Perfect. Don't forget the x equals when you're naming your axis of symmetry. How do I find the second number in my vertex? Plug it in. We take the first number that we got, negative 1, and we plug it into the x's. So I have negative 1 squared plus 2 times negative 1. Negative 1 squared would be positive 1, and 2 times negative 1 is negative 2. Andrew, 1 minus 2 is? Negative 1. Good job. So the second number in my vertex is negative 1. So let's go ahead and graph our vertex. We're going to go to the left to negative 1 and down to negative 1. And I'll graph my axis of symmetry too. It's going to be that dotted line that goes right through the vertex. All right, now when we're dealing with standard form, we can use our C to help us with the next point. Valentina, what's our C?
Our C is 0.
0. So C is our y-intercept. That is where our graph crosses the y-axis. So we cross the y-axis at 0, right there. So I have a point at 0, 0. So the C is where we cross the y-axis. Now that I have 2 points on my graph, do I know where my third point's going to be? Where? Negative 2, 0. It's going to be the mirror of that point. The same thing, but on the other side of my axis of symmetry. That axis of symmetry acts as a mirror. So if you have a point to the right side, you're going to have that same point on the left side. Once you have 3 points, you can go ahead and draw your parabola. Because that's our y-intercept.
So we plot the y-intercept when making a graph?
Yes, when it's given to you in standard form. So when it's given in standard form, the C is going to be an additional point unless your graph goes through C, which we'll see an example of that. All right, so now we want to see if this is a maximum or minimum. Is our vertex at the highest point of the graph or the lowest point? Lowest. So this is at the lowest point of our graph. Is that going to be the max or min? Minimum. Because it's at the lowest point, it's a minimum. So we don't have a maximum. You could say none or just cross it off. What is our minimum value? It's just the y, which is negative 1. So minimum is negative 1. So whether you have a max or min, that is the y from the vertex. What's our domain? All real numbers. Your domain is always all real numbers. No math required for domain. All real numbers. Now our range is always y. It's either going to be greater than or equal to or less than or equal to whatever our y is. So since our graph is pointing up, do we think y is greater than or equal to -1 or less than or equal to -1? Greater than, because we're talking about y values that are greater than. These are going up to numbers that are bigger. So greater than or equal to -1. It's always going to have that or equal to. You just need to figure out if it's going to be greater than or less than. But it'll always be equal to also. So if our parabola is opening up, the vertex is going to be a minimum. And then y will always be greater than or equal to. If our parabola opens down, this will be a maximum, and it'll be y is less than or equal to. All right, let's do one more in vertex form on the next page. Or, sorry, standard form. This one is standard. So let's do standard form, the last question on the next page. So again, this is standard form. These two above it are vertex form because they have the parentheses squared. So these two are vertex form and vertex form. We'll do one of those after we do this one in standard form. So standard form, we have to use our formula to find our vertex and axis of symmetry. What's the formula? -b over 2a. What's our a? 2. What's our b? -8 and c? 1. So let's plug in. We have -8 over 2 times 2. So it turns to +8 over 4. Andrew, what's 8 over 4? 2. So Andrew, what is 2?
Well, 2 is the first number in your vertex.
2 is the first number in our vertex. What else?
You gotta plug in 2 for x and figure that out.
Awesome. Let's plug in 2 for x and find the y. So I'm going to do it on the side over here. We have 2 times 2 squared minus 8 times 2 plus 1. Make sure you follow your order of operations when you're doing the math here. 2 squared is 4, and 4 times 2? 8. And then 8 times 2? 16. So we have 8 minus 16 plus 1. What's 8 minus 16? -8 and -8 plus 1? -7. So what is -7? The y, the second number in my vertex. Let's go ahead and graph our vertex. So we're going to go to the right 2 and down 7. Before we even find another point on our graph or do anything else, do we know if this graph is going to open up or open down? Why is it going to open up? Because A is positive. So whenever A is positive, it's going to open up. It's going to be like a smiley face. So you can always keep that in mind when you find your next point, just to double check to make sure you found the right vertex, you found another second point, and your graph opens up. What is my axis of symmetry? X equals 2. Do not forget the x equals. If you don't put the x equals and only put 2, you will get points off. So don't forget the x equals. So now let's find another point on our graph. So since it's standard form, what else do we know? What other point do we have here? The y-intercept. What's our y-intercept? 1. This is our y-intercept, so that's where we cross the y-axis at 1. Let me draw my axis of symmetry 2 here so we can see. All right, now that I have 2 points, where's my third point going to be? The mirror of it. So since that y-intercept is 2 spaces away from the axis of symmetry on the left, I'm going to have another point that's 2 spaces away on the right. Now we can draw our parabola. Perfect. Any questions on how we got the parabola? We're all good with that? All right, let's answer the rest of the questions here. Our vertex, is it at the highest point or the lowest point? The lowest point. So is this going to be a max or minimum? So we can go ahead and cross off maximum. We don't have one, so you could either say none or just cross it off. What's our minimum value? -7. It is always the y. So since our x repeated in the axis of symmetry, the y repeats in the max or min. What's our domain? All real numbers. Domain is always going to be all real numbers. You can abbreviate ARN if you want to, but it is all real numbers. And what would our range be here? Awesome. Y is greater than or equal to -7. So again, we use our y value. It repeats. And because our graph is opening up, we're talking about values that are greater than -7. Any questions here? Let's practice one in vertex form. So let's do the one right above it. So whenever we have those parentheses squared and it's in vertex form, we can clearly identify the vertex just by looking at it. What would our vertex be here? Careful, because we always have to change the sign of our h. So it'll be +2, comma, what? -3. It's what we're adding on the inside and what we're adding on the outside, but you have to change the sign of the h. Even if it's positive. If it said x + 2, you'd change the sign and make it a -2. Yes. I'll say change the sign of the x in the vertex. What would our axis of symmetry be? X equals what? 2. Perfect. It's always the x from our vertex. And don't forget the x equals. So let's go ahead and graph those. We go to the right 2 and down 3. And our axis of symmetry goes right through it. Now, how do I find another point on my graph here? This isn't standard form, so I can't just use the y-intercept. What do I need to do? I want to plug in an x value that's close to the axis of symmetry. So to find another point, plug in a number close to the axis of symmetry. So what's a number close to 2? 1. Sure, let's plug in 1. So I'm plugging 1 into the x here and then solving. So I have -1 times 1 minus 2 squared minus 3. So we plugged in 1. So for our second point, we plugged in 1. We're going to find the other number. Find the y. When you do this, you have to follow your order of operations. Make sure you do it in the order of PEMDAS. What's the P in PEMDAS stand for? Parentheses. So what's 1 minus 2? -1. What's the E stand for in PEMDAS? Exponent. What's -1 squared? +1. What's -1 times +1? -1 and -1 minus 3? -4. So the second point here, the second number in my second point is -4. So we're going to go to our graph. We go to the right to 1 and down 4. Do I know where another point's going to be? Where? The mirror of it. So I just put that same point on the other side of my axis of symmetry. Then I draw my parabola. It was 1 -4. Because we plugged in, we plugged in 1 for the x. So you're going to pick a number for the x and then solve it to get the y. All right, so now is our vertex at the highest point of our graph or the lowest point? The highest, so if it's at the highest, is it going to be a max or min? Maximum. So our maximum value is going to be what? -3. Perfect. It's always our y. So we can... the y in the vertex, yep. You always use the same number from the vertex. So once you find your vertex, those are the only numbers that you're going to use for the rest of the questions. For your axis of symmetry, the maximum, and the range, you just repeat the numbers from the vertex again. Just got to know which one you're using the x and which one you're using the y. The maximum is the y. So you can either cross off minimum or say none. What's our domain? Domain, what's our domain? All real numbers. Koi, what's our range? Y is less than or equal to -3. Perfect. It's less than here because our graph is going down. We're talking about numbers that are less than -3. All right, we good on this graph? We're going to practice graphing again on the next page. Let's look at the one up top. This is intercept form. So when you have two sets of parentheses, you can easily find your x-intercepts here. What would my x-intercepts be? Awesome. You always flip the signs of both of them. So our x-intercepts would be -4 and +2. So our graph is going to cross the x-axis at -4 and +2. Now our vertex and our axis of symmetry is going to fall right in between those. So to find out where my x value is in my vertex, I'm going to add these two numbers together and divide by 2. So -4 plus 2 divided by 2. So we get -2/2, which simplifies to -1. So my axis of symmetry is going to be at -1, right in the center of those 2 points. Your axis of symmetry is always going to fall in between those two numbers. So add them together and divide by 2. So my axis of symmetry is x is equal to -1. So what would the first number in my vertex be? -1. Same thing as our axis of symmetry. How do I find the second number in my vertex? Plug in the -1. So I'm going to plug in -1 into the x's. So that'll be -2 times -1 plus 4 times -1 minus 2. Follow your order of operations here. Do the parentheses first. -2 times 3 times -3. And -2 times 3 would be -6 times -3 would be +18. So I'm going to go to my graph. I go to the left to -1 and up 18. It's going to be way off of our graph up here, but that's fine. Does it make sense that our graph opens down? What was our A? -2. So it makes sense that our graph opens down because our A was negative. So you can always just check your work, make sure your A matches with what direction your graph opens. All right, let's look at 11. So 11 is what you guys did on Tuesday. This is from part 1 of 3.6. So you're only going to have one question from 3.6, and it's going to be a question exactly like 11. Which 11 is super similar to the questions that we just did. We are graphing. So is the first equation here, we just graph one at a time, is our first equation in standard form or vertex form? Standard form. How do I find the vertex when it's in standard form? -b over 2a. So what's our a? What's our a? -3. What's our b? -12. And c is -9. So let's plug in. So we have negative 12 over 2 times negative 3. So that would be 12 over negative 6, which simplifies to what? Negative 2. So negative 2 is going to be the first number in our vertex. Andrew, how do I find the second number in the vertex? Plug in negative 2. Perfect. So I'm going to plug it into the x's. So I have negative 3 times negative 2 squared minus 12 times negative 2 minus 9. So negative 3 times 4 would be negative 12. What's a negative 12 times negative 2? 24 minus 9. So this would be 12 minus 9, which is 3. So 3 is the second number in my vertex. Let's graph our vertex. I'm going to go to the left to negative 2 and up 3. Now looking at this question, is our graph going to open up or open down? It opens down. Why? Because our a is negative. So we know that it's going to open down. When it's in standard form, do I know what other point I have here? What's another point? Negative 9, my y-intercept. This is where I cross the y-axis. So I cross the y-axis all the way down here at negative 9. I'm going to draw my axis of symmetry, because where's my other point going to be? The mirror on the other side. So since I'm 2 spaces away on the right side of my axis of symmetry, I need to be 2 spaces away on the left too. Now I'm going to erase my axis of symmetry just so I don't get confused here, because I'm going to end up with 2 graphs. Is my graph going to be a solid line or a dotted line here? Solid. Anytime you have a less than or equal to or greater than or equal to, it is a solid graph. If you had a greater than or less than, this is a dotted graph. So we have a solid line here. So I'm going to connect my dots with my parabola with a solid line. Now, when you are dealing with inequalities and graphing, you are going to have to shade. Let's see who remembers from the video from Tuesday. How do I know where I'm going to shade? Plugging in a number. It doesn't have to be in the parabola. It could be anywhere, but just make sure you know where your point is. I always recommend plugging in 0, 0 unless your graph falls on 0, 0. If your graph goes through 0, 0, you can't pick a point. You can't pick a point on the line. It's either clearly got to be in it or clearly got to be out of it. So to shade, we're going to plug in 0, 0 into the x's and y's. So I'm going to plug in 0 into x and 0 into y in my first equation up here. So 0 is less than or equal to negative 3 times 0 squared minus 12 times 0 minus 9. So 0 is less than or equal to negative 9. Is this true? No, it is not true. So am I going to shade where 0, 0 is or where it's not? Where it's not. Since it's not true, you shade where it's not. So am I shading inside or outside? Inside, because 0, 0 is outside and I need to shade where it's not. So I'm going to shade the inside. Everybody good with that one so far? So it's just like graphing before, you just need to know if it is a solid or dotted parabola, and you have to shade. Don't forget to shade the inequalities. We still have one more inequality to put on this graph. So let's do the next equation here. So we have y is greater than x squared minus 4. Andrew.
You gotta do the negative b over 2a.
Awesome. We want to find our vertex, which is negative b over 2a. What's our a?
1.
1. What's our b?
-y.
Careful. Remember, b is the number in front of the x. Do I have an x here? So what's our b?
1. 0.
0. Because I don't have an x, b is 0. What's our c? -4. So we have -0 over 2 times 1. What's 0 over 2? 0. So for our vertex, the first number is 0. How do I find the second number? Plug it in. So I'm going to plug it into x. So I have 0 squared minus 4. What's 0 minus 4? -4. So my vertex is at 0, comma, -4. So I stay at 0 and go down -4, put a point there. Now typically, I would use my c when I'm in standard form to find another point. But what's my c? -4, which is the same point that I just put on my graph. Just so happens that my vertex is the y-intercept. So what do I have to do to find another point? Plug in a number close to it. We want to plug in a number close to our axis of symmetry, which is 0. So what number should I plug in?
1.
Sure, we can plug in 1. Perfect. You can plug in any number you want, but remember, the farther away from your axis of symmetry that you go, the bigger the numbers are going to be, which will probably end up on your graph. So let's pick 1. So we have 1 squared minus 4, which is 1 minus 4, which is -3. So we plugged in 1 and got -3. So this is our second point. So we're going to go to the right to 1 and down -3. Once I have 2 points, do I have a third?
Yeah.
What's our third point? The mirror of it. Now, is this parabola going to be a solid parabola or dotted parabola? Why dotted? Because it's just greater than. So this means that it's going to be dotted. So I'm going to have a dotted parabola right through those 3 points. We're not done. What do I have to do next?
Shade.
Figure out where I'm going to shade. What's a number I can plug in to test to see where I'm going to shade?
0, 0.
0, 0. 0, 0 is always a good number unless your graph falls on 0, 0. Then just pick a different number. You can pick any number you want for your x and y, but just make sure you know where that point is on the graph. So 0, 0, we're going to plug in 0 for x and 0 for y. So 0 is greater than 0 squared minus 4. Is 0 greater than -4? Yes, it is. Be careful. Be careful. Don't rush it. Yes, it is. So if it's true, am I going to shade inside or outside? Inside, because 0, 0 is inside. So I want to shade where 0, 0 is. So I'm shading on the inside. Now for your system of inequalities, when you've got 2 of them, like this graph, you only keep the overlapping parts. So everything that's shaded gets erased except for the overlapping shaded. You want to keep your graphs there, but just erase the shading that's not overlapping. So I'm going to erase the orange and the blue, and I keep the green. If you want to bring colored pencils for the quiz tomorrow, you can do that. I would just suggest maybe lightly shading. That way it's easy to erase once you figure out where they overlap. So you only keep the overlapping part.
This one?
Yes.
Oh, like, so let's say you figured out for the last one to shade, and like you know that you're gonna have to only shade the inside part. You have to shade the
No.
rest of it and then erase it.
No, you can just shade like the inside part.
Okay.
Yeah.
For the first parabola, why did you shade inside?
Because we plugged in 0, 0, which happened to be outside of the first parabola. And since it was not true, we shade where 0, 0 is not.
Oh.
So it just depends on where your point is that you picked. If you always want to pick a number inside, you can always pick a number inside your parabola. If you wanted to pick like -2, 0, and then test that, you'll find out that it's true. So then you shade inside. So just have to see where your point that you picked is. All right, 12 is the same. Let's go to the next page. So on the next page, it asks us to identify the vertex and describe the transformation of each. So this is 2.1. So in our first question here, what's our vertex? -2, 7. Perfect. Remember, it's what you're adding inside and what you're adding outside, but you change the sign of your H. Now let's identify our transformations. What happens when we multiply 3 on the outside? Is it a stretch or shrink? Stretch, because it's bigger than 1, so it's a stretch. What about when we add 2 on the inside? What type of transformation do we have here? 2 to the left, so we go to the left, 2. What about when we add 7 on the outside? Up 7. Make sure you know your transformations. Let's look at the next one. What's our vertex here? +4, -6. Perfect. Now let's identify our transformations. What does the negative do?
Shrink.
No, not shrink. Reflection. A reflection on which axis? The x-axis, because it's outside of the parentheses. If it was inside the parentheses, it would be a reflection on the y-axis. What does the 1/2 do? This shrinks. And then -4 on the inside. Right 4. And down 6. Awesome.